We are on Unit 2, Lesson 6 today. So your warm-up about chatting, all right, class is officially started now. Your warm-up was to, if you were a boy, evaluate your expression when n is 5, 7, 13, -1 for that one. And then if you're a girl, you should have done the same thing, but for that expression. Boys, what did you get when you plugged in 5 into the first one? Yes, Landon?
8.
Anyone, any boy get something other than 8? All right, girls, what did you get from plugging in 5 into your first expression? Girls? Anyone? 8? Anyone get something other than 8? All right, so if you did, you are correct. For both expressions, it was 8 for when you plugged in 5. So just to kind of review, when you plug something in for a variable, like they say n equals 5 or something like that, that's called the substitution property. So for the first one, when I plugged it in, it would look something like this. Anytime you plug stuff in, you need to use parentheses. All right, because sometimes it can get confusing. So just make sure you use parentheses. You are welcome to use Desmos or whatever calculator you can use, but you just have to be smarter than your calculator. Like, it's only as smart as you are. You need to know how to enter stuff in your calculator to make it look exactly like how it does on your sheet. So if you are having issues, maybe consider putting the numerator in parentheses and then the denominator. If you don't know the button for the exponent on most calculators, it looks something like that. Or you have that key on your keyboard, you hit shift and then 6 issues and then that button. So you could have used a calculator and gotten the answer easy. Otherwise, you would really have to know your order of operations. So what comes first in order of operations? Good. So let me remind you, Pen does kind of like the shorthand. P comes first for parentheses. Now, yeah, there's parentheses around here, but we're focusing on simplifying what's inside, not outside. So inside, is this fully simplified? Inside the parentheses, isn't it? There's nothing else being done for the 5 inside the parentheses, right? So that's not the first step there. But down here, are these parentheses fully simplified? No, because I can do the operation 4 minus 3. What's 4 minus 3? 1. So I'm going to copy everything over. 5 squared minus 9 over 2 times 1. And now that's no longer considered parentheses. It's considered multiplication. Inside the parentheses, it's simplified. If that makes sense. So we're done with the P. What does the E stand for? Exponents. So do I have any exponents in this? Yes. What is it? So what? It's 5 squared. You guys know what that is? Perfect. So if you didn't know, it's not 5 times 2. It's saying the base number times itself. That makes sense. So 5 times 5. I know you can probably do multiple steps at once, but we're just gonna follow the order. Now, remember, multiplication and division is in the same step. It just depends what comes first when you're going left to right. Sometimes you'll divide first, sometimes you'll multiply first. The division sign, or this in the fraction bar, does mean divide, but anytime it's in fraction form, fully solve the numerator and then fully solve the denominator before dividing. So in this one, I do have multiplication on the bottom. That's 2 times 1. So what's 2 times 1? Good. You don't divide until the numerator is fully worked out. Kind of like having parentheses when it's in fraction. You have to fully work out the top and then divide by the top. All right, so then fully work out the top. What's 25 minus 9? 16. And then divided by 2 is 8. So whether you did that or not, I'm sure you probably combined some steps, but that's like how you do order of operations, just reminding you. And then girls, you probably went through a similar process. I'll show you what it looks like when we plug in for a different problem. So any questions on number 1? All right, what'd you guys get for number 2, boys? Ryan?
20.
20, anyone get something different? All right, girls, what'd you get? Good share. Did you're welcome to use a calculator, Jalen. It is also 20. So you're both correct. This time I'll show you what it looks like when we plug in 7 into the girls' equation. So anytime you plug stuff in, just use parentheses, that's good practice. So I have 7 being plugged in to the n plus 3 times the n minus 3, so 7 minus 3 over 8 minus 3 times 2. Lots of stuff going on. So first, order of operations. Do I have anything inside parentheses that needs to be worked out? Yes, like this over here. What's 7 plus 3? 10. This inside is fully simplified, so that doesn't fall under this anymore. So we're done with that. Now, any exponents in this one? Nope. Any multiplying or dividing that I have to do? Yes. So over here, the 10 will be times whatever this fraction I get. So fractions are kind of unique. They have to be fully worked out before you can multiply them. So we'll kind of table that. But in my fraction, I do have to multiply down here. I'm going to copy over what I already have. The parentheses can go away around the 10 now because there's nothing else outside of it. But what is -3 times 2? So on the bottom, it should be 8 minus 6. All right, so no more, well, I mean, we will have to multiply once we figure out what this fraction equals. But now any addition or subtraction that I have to do. Good, and the numerator actually. So, and also, even though there's no addition in this problem, that is also in the same step. So you would do that from left to right as well. So I'm just gonna copy the 10 over. What's 7 minus 3? What's 8 minus 6? And then now we're kind of back to the multiplication division step. But we need to work out that fraction first. So it's 4 divided by 2. And then what is 10 minus 2? All right, good. It also would have worked if you did go from left to right. If you did 10 times 4, which is 40 divided by 2, which is 20. Questions on that? All right, just showing you what it looks like plugged in. Feel free to use a calculator. Just also make sure you know how to use your calculator to do that. Boys, what did you get when you plugged in 13? What'd you say, Amari? 80 is correct. Girls, what did you get when you plugged in 13? That is also correct. Boys, what'd you get when you plugged in -1? -4. Girls, what did you get when you plugged in -1? And girls, are you saying that because you're kind of noticing a pattern, or did you actually get it? You got a +4? Okay. Well, it is a -4. And it's just by chance that we happen to be the same for both boys and girls. If you plug it in or you use the calculator to plug it in, these would be the correct answer. If there's any specific ones you want to see, let me know. Kind of save that for later though, because we have other things to go over. So now that we've done that, and you can go back to the solution. Or don't, but either way you guys will try. So the goal for today is to investigate what makes two equations equivalent. You'll know that you're successful is if you can tell whether two expressions are equivalent and explain why or why not. If you can know and identify the moves that can be made to transform an equation into one. And if you can understand what it means for two equations to be equivalent and how equivalent equations can be used to describe the same situation in different ways. I'm recording right now. I'll link it in the slides. Your practice will be a puzzle piece. And your next quiz will be Wednesday next week over lessons 6 through 11. So yeah, the quizzes are going to be a little more frequent so that you have more checks for your understanding, that you can actually narrow down what you're struggling with and for unit tests. With the puzzle pieces, I kind of want to change the way that we go about that. I'm really going to be looking at the lessons. I mean, I've always been looking at them closely, but I'm really going to be looking at them more to see what is absolutely necessary and what we can cut out. Because right now the lessons are too long. It's been longer than I've done in the past, but with the curriculum, like I have to teach it, right? But I'm going to try and shorten them as much as I can. And then with the puzzle pieces, normally that's like your independent practice, but I'm actually going to have you work with your people around you. And when I say that, I mean, like if I'm a group of 3, maybe like on that side of the room, I'm unrandomizing the homework from here on out, by the way. So you'll all have the same number 1. But essentially, I don't want you guys to move on unless you agree on an answer. If you disagree and you can't agree, let me know and I'll help you try and figure it out. But otherwise, you guys should work together on it and kind of go at the same pace. So helping each other. If there is someone in your group that's kind of useless, not that they're not trying, but like that they're just kind of mooching off your answers and not contributing to the conversation, then don't share your answers with them. All right. The purpose of this is to work it out, to come to conclusions. Right now, what I'm hearing, not necessarily even from my students, but from other like athletes that I know, like my athletes, is that they're not understanding the practice. So maybe if we spend more time on it in class and work on it in groups, we can understand it more. And honestly, the completion rate for the practices has been decreasing, so hopefully that helps. So any questions on that process? So faster we get through the lesson, the more time we have to practice with our groups before you're like on your own. And all right, so from the warm-up, were you surprised that these expressions have the same result for different values of x? So like what they're asking is you plugged in different numbers for n, but for the boys and the girls, we ended up getting the same result. All right, it won't necessarily be like that all the time, but it happens to be like that for this. Do you think that the two expressions will have the same value no matter what value of n is used? Right? Yes, no, maybe so. Because if it was the same when I plugged in 4 different values for n, do you think that if I added an additional problem here, I made you plug in, I don't know, 100, would I still get the same answer for boys and girls? Probably. That seems to be what the trend is so far. So with that, I'm going to kind of show you the vocab. I don't know if there's anywhere on the note sheet of vocab. Probably not. But I want you to understand that those would be examples of equivalent expressions. So they would be equations that have the exact same solution are equivalent to each other. So if I made it an equation and I still had the same exact solutions for both, then they'd be equivalent equations. Just so you know, you don't necessarily have to write that down. But equivalent equations have the exact same solutions. So you could shorten it like that. Equivalent equations have the exact same solutions. So what's the difference between equations and expressions? Yes, Brianna?
Equations have expressions don't.
Perfect. So equations have equal signs, expressions don't. So in our warm-up, that was an example of equivalent expressions, which are equal no matter what value we use for the variable. Good. All right, so then on to this activity, which is also printed on your note sheet. You're going to write as many equations as possible that can represent the relationship between the ages of 2 children in each family described. And if you're using a variable, just be able to tell me what the variable represents. So do you think you need to see one? I kind of want to leave that. Okay, fine. So I have in family A, the youngest child is 7 years younger than the oldest, who is 18. And it wants us to write equations. Equations have equal signs. So make sure that your answers all have equal signs in them, otherwise they're not equations. So what's an equation that I could write for this, Amari? And what will X represent? So the youngest child's age. Anyone disagree with that? Is that incorrect? All right, what's another equation we could write? Anyone disagree with that? All right, I'm gonna challenge you to try and come up with others. And then I'm also gonna challenge you to try this one from scratch. So I'll give you about 2 minutes to see what we get. All right, so any other alternative equations that we could have come up with for A? Or is that it? Is there no other option? What if maybe I wanted the 7 to be by itself? How could I move the X to the other side? I could subtract X on each side, and now I have another equation. I have 7 equals, and you can write it 18 minus X, or negative X plus 18, same difference. Anyone come up with something else? What would X equal? 11. But then I also write that, isn't that an equation? Yeah, equations don't have to always have variables. Sometimes they don't even have to have any numbers, sometimes they're all variables. But what they do have to have are the equal signs. So there's plenty of options out there. You're actually trying?
No.
Oh. Well, there's plenty of options out there. Anyone want to see if theirs is right? Or you think yours is where, what was the, you say 11 plus 5? Oh, okay. Okay. So in family B, the middle child is 5 years older than the youngest child. Anyone have an equation for that one? Okay, Amari, what did you say? 11 plus 5 equals 1. 5. Okay. What did someone say something over there? X plus 5 equals M. Okay. I was saying we're doing. Ryan? Okay. Let me just check my book real quick. Because are we able to actually figure out what the middle child's age is? No, we don't have enough information. We can definitely write an equation, but like this top one, there's no way I can know that that kid is actually 11, right? So I would have to change that to an unknown. What do you want the variable to be? So what are we saying that y equals? So let's say that y is for youngest child. M is for middle child. So even if you use other variables, that's fine, but let's just try to get on the same page. So it would have to be the youngest child plus 5 years would give me the middle child's age, right? What are some other equations I could write now that we know this one is correct? Yes, Jalen? M minus 5 equals y. Any others? What if I want both variables on one side? What could I write? How could I move this y? Jalen? Good, and then now I have 5 equals m minus y, or negative y plus m, even that would be the same. Anything else someone wants to share? Okay, then make sure you have those examples written down. So consider the equations you wrote for each situation. Are they all equivalent? Yes or no? So like for the first one, are these all equivalent to each other? Yes, whatever I plug in for x, I should get the same answer. Or if I solve for x, I should have the same answer. What do you think it means for two equations to be equivalent? Kind of a repeat of our definition. Equivalent equations have same solutions. I don't know if there's anywhere for you to write that, but just FYI. Now, this is a continuation of our last example, which is also printed on your paper. So Tyler thinks the relationship between ages of the children in family B can be described like this, where M is the age of the middle child and Y is the age of the youngest. Explain why Tyler is right. So are we saying that he's wrong? No. So strategy for your test, there's not really, like when I give you a constructed response, I'm not going to give you something like that. And then the answer is actually Tyler is wrong. All right, we're telling you he's right. You just need to be able to explain why. So think about that for 1 minute, maybe write it down on the paper. All right, why is Tyler right? Maybe if I rearrange this to look more like this equation. Except just with the numbers that we use, so moving the 5 to the other side by adding 5, moving the Y to the other side by subtracting it, we get this. Why are these two box equations equivalent? Yes, Ryan?
2 times all by 2.
He times every single term by 2. If you do something to both sides of the equal sign or like to every single term, so if I did it to both sides of the equal sign here, times 1 by 2. That's something that we learn in solving, right? You can do anything to both sides of the equal sign as long as you do it to both sides, it's equal. And then once you distribute that to, is how you get the exact same thing that Tyler's on. And then if I were to solve, like maybe if I had more information, the M and the Y would be equal in both of them. Now look at this on your paper and on the screen. Are any of these equations equivalent to one another? And if so, which one? Look at it, decide if any of them are equivalent. All right, are any of these equations equivalent to one another? Amari? The first two are equivalent to each other. Why do you think so? So minusing 6 on each side of the first one, that would cancel out this over here. I get 3a equals 15 minus 6, which is 9. So we can rearrange this. We're not changing the values of anything. We're doing the same operation of both sides. And we can use equivalent equations. Did anyone else find equivalent equations? Gray, did you have your hand up?
No, I'm checking.
Anyone else? Ryan?
Third one.
The first and the third one, how did you determine that?
Divide them all by 3.
Divided this by 3 and this by 3, is that what you mean?
Yeah.
And then you got A equals,
Well, it's like 3 plus. You divide 3a by 3, 6.
3A by 3 is A, right? Is that what you're saying? And then the other side is.
The original problem for the first one.
Oh, got it. So original problem, divide each one by 3. And we get, that cancels out, 6 divided by 3 is 2, 15 divided by 3 is 5, which again, these would be equivalent. Any other ones? Jalen? The first and the last one, and how did you determine that? So that's a really interesting conclusion. So we wrote both into decimal, then for Desmos, did it read the A's? So we wrote both equations into Desmos. Desmos doesn't read A's for equations, so it will read X's and Y's. Wrote both equations into Desmos and they overlap. So they must be true. That's actually like a really like higher level answer. And you'll see that later on in this unit when we get to the different other topics. But that's a great answer. If they overlap, they're the same exact line. So we have to design. So we're saying the first and the last are equivalent because they overlap. So in that sense, shouldn't like these two be equivalent then? Well, if this one's equivalent to that one, and this one's equivalent to that one, shouldn't these two be equivalent to each other? Right? Yes. And then wouldn't then these two be equivalent to each other? Also, yes, because this one's the same as this one, and this one's the same as that one, these must also be the same. So the answer is they're all equivalent to each other. You can manipulate any one of these equations and or solve. Maybe you can't manipulate all of them. You make it all. But you can solve each one, and A will equal what each time? How do you get the A by itself? Subtract 2 on each side, I get A equals 3. Over here, do the opposite of what's being done, A equals 3. Same thing over here, A equals 3. 3. Well, what's opposite of dividing by 3? Multiplying by 3, so that's what I do on each side here to get rid of that 1/3. And A equals 3. So that's another way you could have determined that they're all equivalent. Good. Great lesson. Couple things. Hold on, I'll get to you in a second. Tomorrow I won't be here. I get full for district training like once a month. So I'm the math mentor for Algebra 1 too. So I get the privilege of going to training lessons once a month about this new curriculum when I teach other people. So anyway, that'll be like a normal thing. I know it seems like I'm asking a lot, but I'm actually working. I'm usually coaching and or doing one of those trainings for weekly classes. So just so you know, anytime I'm asking, there is something for you to do in Schoology. It's actually already in there. So tomorrow when you come to class, the sub will have this information too. Stop talking. I don't want your voice to be on the recording while I'm talking. I said stop talking. You click on this week's folder. And sometimes you guys drive me crazy and you're like, where is everything? And literally everything's labeled by the day. But you click on this week's folder. You'll click on today's date, which tomorrow will be the 14th. Click on it. And it tells you exactly what you need to do. So there's still stuff that you're responsible for, even when I'm not here. You don't just get like a day to relax. This is the instructions I'm leaving for the subs that I'm telling you right now. You're learning lesson 7. I already recorded it and uploaded it into the slide. You're going to turn in your note sheet, so you'll get the note sheet from the sub. If you're not here, take notes on your own paper and upload it. But that's the point. To be an easy 10 classroom check, because it's not even based on accuracy, it's based on doing the notes that are already in. And then your puzzle. So that's what you're responsible for, watching the lesson, taking notes, and turning in your puzzle. If you don't do it, don't do it, but we're not giving you more class time to get it done. We're giving you tomorrow while the stuff is here. So any questions? All right. And get to work on your